Can somebody remind me that I'm recording at the end so I stop? Happy Friday. How was everybody? Excited for the weekend? Yep, I'm ready. It was snowing this morning. I was taking my daughter to school. I'm not okay with that. Anyways, continue. South Dakota. At some point in my life, I need to stop complaining. It's not going to happen, but I keep telling myself that. No, not going to happen. No. I'm moving. All right, so I updated the schedule a little bit. We're not going to have class next Friday, so unless you guys are super sad and really want to come, okay, no fights. So today we're going to do 4-2. Monday will be 4-3, 4-4. No class next Friday, and then we'll come back the next week. That allows us to take our Chapter 4 test on Friday, which I think I'm more excited about than having it on a Wednesday. I went through yesterday, yes, and I updated all your grades currently on the MyUSF site. So if at some point we communicated and I opened up homeworks and let you get them, turn them in late, I would encourage you to look at MyUSF to make sure that your grade is correct, because there's some people that didn't tell me that they finished their grades, and I don't have enough time to go through every single person's grade to see if you had turned it in after the deadline, if that makes sense. So anyways, if that is you, let me know. Look at your stuff. Look at your stuff on MyUSF, make sure your grade is correct. So with that being said, I also changed the last chapter. Instead of having 2 more tests, because I realized we're actually supposed to have a test on Chapter 10 and a test on Chapter 5, I'm just going to combine those. So basically, after this Chapter 4 test, we only have 1 more test left. And remember, if at that point you have an A in this class, you don't have to take the final. So, and a lot of you guys are actually there. So good job, keep working hard. We're almost to the end. We're going to get there. Anyways, sign out, and I'll say this all next week. No class next Friday. And then that following Friday will be the Chapter 4 test. Okay, so on, what's today? Friday. On Wednesday, we talked about exponents, right? So today we're gonna kind of continue going on that same path. We're gonna talk about using zeros in exponent, what that means, and then we're gonna get into this negative numbers exponents, and then we're gonna talk about the quotient rule, and then number 4, you guys actually have on that piece of paper that I handed out. So we're gonna do that as a class together. So if you didn't get a piece of paper, don't worry, I'll get one to you at the end of the class. All right, so let's talk about zeros and exponent. So the rule is for any non-zero real number with base a, anytime you have base a raised to the 0 exponent, you're always going to get 1. Now, the biggest struggle for a lot of people are, is it 1, is it 0, what is it? I don't know. So you just got to kind of you either have to remember the rule or I guess. Or the way I remember it is here. Let me draw out my little, because something we're going to talk about today. So let's talk about, somebody give me a number less than 5. 4. Okay. Because we're gonna talk about negative exponents as well. So let's just talk about this for now. So does anyone know what 4 cubed is? That's 4 times 4, which is 16 times 4. Does anyone know what 16 times 4 is? 64. Good job. Oh my goodness. And then does anyone know what 4 squared is? 16. And does anyone know what 4 to the first power is? 4. Okay. So this is my roundabout way of trying to get you to understand why anything to the 0 power is 1. But a lot of people just remember it. They struggle with remembering things in math classes that on the test, I normally don't try to do this, but you might have a 1 and a 0, and half of you will probably pick 0 and half of you will probably pick 1, right? Okay. So 4 squared is 64, or sorry, 4 cubed is 64, 4 squared is 16, 4 to the first is 4. How do we get from 64 to 16? Do you guys know? What can I divide 64 by? Divided by what? 4. Do you guys see that? How do I get from 16 to 4? Divided by 4. So how am I going to get from, the question is, what is this thing, right? Well, what is 4 divided by 4? 1, and that's why that is. Now, we're going to get into negative exponents. Does anyone know what 1 divided by 4 is? 0.25, also known as 1 over 4, right? 4 to the negative 2 then, this one gets a little bit trickier. What's 1/4 divided by 4? 1 over what? You guys know? No. If I had 1/4, right? Not to talk about fractions too much, right? That's 1/4, right? And I have to divide each of these into how many pieces? 4. Does anyone know how many pieces I have there? What do you think? 16? Right? So if I have a 4th, right? And if I divide each of those pieces into 4, I've got 4 here, 4 there, 4 there, and 4 there. Okay? So that's how anything raised to the 0 is equal to 1. Because basically what you're going to take is you're going to take that number and just divide it by the base. Which that'll always give you 1. Does that make sense? Okay. Go ahead and try these ones. Be careful. Think about order of operations. I forgot markers. I ordered some, but Amazon won't come here till Sunday. I'm sorry. I did not forget. They're going to be colorful too. Like bluish, greenish. Yes. Yes. Sure. What's your third one? What's your third one? What's your third one? Sure. You change it? Yeah. Yes. Okay, let's talk through this real quick. What's 7 to the 0 power? We just said it is 1, right? Order of operations. For this one, because the negative 7 is parentheses, what's anything raised to the 0 power? That is also 1. But this one, what's it going to do first? 7 to the 0, which is 1, and then it's going to bring in that negative. So again, just be careful of that. We talked a little bit about that last class. Remember, I think at the time, I can't remember what it was, but. And then the last one, 13 to the 0 power, I think is 1. 2 to the 0 power is also 1, and 1 plus 1 should give you 2. Okay? So again, just be careful on these ones, right? So order of operations, it's going to do the exponent first, and then it's going to bring in the negative 1. Okay? Any questions on 0 exponents? I feel pretty good on those. If you can remember as 1, honestly. That's the biggest thing. All right, so let's talk about negative exponents. This is, we kind of talked about it already, but this is for any non-zero real number a and any integer n. If you have a to the negative n, that is going to equal 1 over a to the n. So here's how I remember it, and it's kind of weird. So I have a 3 to the negative 2 power. What is that? If I were just to ask you, how do you write 3 as a fraction, you would put 3 over what? 1, right? So can I put 3 to the negative 2 over 1? Right? That works, right? Okay, so this right here, you guys didn't know this. Maybe you did. This guy right here, so one thing with exponents, we can't have negative exponents, okay? That's like a big no-no. Like, no, I'm not going to say that. Okay, anyway, it's a big no-no, okay? So this guy right here is called the magic fraction bar. Did you guys know that? Okay, so that's the magic fraction bar. Okay? It is, it's magical. What happens is when exponents cross the magic fraction bar, maybe it should be magical fraction bar, real magical fraction bar. When negative exponents cross the magical fraction bar, guess what happens to them? They magically become positive. So this guy, who's on top, is going to cross the magical fraction bar, and he's going to become 3 to the positive 2, but now he's in the denominator. Okay? And then you're going to put a 1 on the top. So that's what happened there. Okay? Magical fraction bar, when he crosses it, when an exponent crosses it, it becomes positive. Okay? Magical fraction bar. So what does that mean? What? I forget how I did this. We'll do this one. Okay, here. 3 to the negative 3, what's that technically over? 1. What's it going to do? Cross the magical fraction bar. What happens when it crosses the magical fraction bar? Yes. Oh my. I didn't even like... Ugh. Does that kind of make sense? Okay, this one. What's the first thing I should do with this negative 2? Remember from Wednesday? Power rule. What should I do? Distribute? Sure. Here's what I do. Ready? Another one. Ready? It's going to blow your mind. When you have a negative exponent, the easiest thing to do is flip the fraction and change the exponent to positive. Okay? So the 2 big things to remember with negative exponents. 1 is the magical fraction bar. MFB. MFB! No, just kidding. It's terrible. That, and then if you have a negative exponent, you do the reciprocal on the inside and change the exponent. So now that that's positive, now I distribute it, so I get 25 over 1, which is just what? 25. What do I do with the bottom one? I have a negative exponent, I don't like it, so what do I do with the inside? I what? Flip it, and what does my exponent become? Positive 2. Now I go back to Wednesday, and what do I do with the exponent? Right, distribute it. I still don't think that's the right term. So I get 6 squared over 2 squared. What's 6 squared? 36. And what's 2 squared? 4. Does anyone know what 36 divided by 4 is? 9. Good job. So negative exponents. Magical fraction bar if you need it. If not, if you have a fraction inside there, flip it. You guys want to see why that happens? Or you don't care? Okay. Let's do what Mr. Dawson said originally. Let's distribute this at both ends of there, right? So I get 1 to the negative 2 over 5 to the negative 2. But those are both negative. I don't like those, so what do they have to do? Cross the... Thank you! They have to cross the magical fraction bar, right? This one crosses down here and becomes 1 squared. This one crosses here and becomes 5 squared. You see that? And what's 5 squared? 25. Good job. What's 1 squared? 1. And we get 25. Which is the same thing we got right there. Right? So that's why it happens. The shortcut, maybe I should have showed that first. The shortcut is, if you have a negative exponent, you flip your fraction inside, your exponent becomes positive. Any questions on those ones? Okay. Go ahead and give these ones a shot. See what you got. And if you guys want, go ahead and change the exponents to numbers. I'm sorry, this one's D over here. I spent like 20 minutes trying to figure out how to put a D in front of that. I couldn't figure it out. So it's like a picture. Perfect. Perfect. So watch D. So that's n to the negative 3. You can't have a negative exponent, right? So I can write that over 1. And then it crosses D. I think I watched too many kids shows. Perfect. Because I'm just pretending I say, and then it crosses the, and then all the kids go, magical fraction bar. I think that's right. Right? I don't know. It's on this picture. Distribute your 3 on the last one, and you got it. Distribute 2 at the top and the bottom. Perfect. You guys ready? Okay, so this one, I don't know how they do it, so I'm just going to do it my way. Magical fraction bar, right? So that should equal 1 over, and I guess this one could cross 2. Why not? 1 over 4 squared, but what is 4 squared? 16, right? So you should get 1 over 16 for that one. The next one, flip it, becomes positive, right? Distribute. I've got nothing. I'm not even, anyways. 4 cubed, I think, is 64 over 1, which is just going to be 64 for that one, right? This one, flip it. I'm going to cheat. 5 squared over 3 squared after distributing, right? So I think this one is 25 over 9. And then this one, you treat variables just like you would numbers. Magical fraction bar, 1 over m cubed is what I was looking for there. Okay? Magical fraction bar. We just did that. Okay, this one. This one looks fun. All right, what do you guys think? I've got 2 to the negative 3 over 3 to the negative 4. I don't like negative exponents, so what do I have to do with both of these? Yeah, cross the magical fraction bar, right? Crosses becomes positive. Crosses becomes positive. I think 3 to the 4th is 81. Right? Sure. 2 to the 3rd is 8. I'm okay with that answer. Okay? Now, this is where the real fun happens. How do I want to do this? Does the 4, I'm going to write a gigantic one. Does the 4 need to move? No, so the 4 stays there. Can I have an x to the negative 3? No, so what does that one need to do? That one needs to cross the magical fraction bar. There's probably like some mathematician rolling around in like their grave that I'm calling it the magical fraction bar. They're probably like, what is this person doing? Does the 7 need to move? No, does it stay on the top or the bottom? Bottom, right? So I'm going to leave that one right there. What about that r to the negative 2? Negative exponent, so that goes where? Magical fraction bar. I'm not a singer. And what about that y? Does that y need to move? No. Does it stay on the top or the bottom? Bottom. So there's my final answer. Did you guys see that? As long as it's a positive exponent, it doesn't move. As long as it's a constant or a number, it doesn't move. This y right here technically has a positive 1 exponent, so it does not need to move. It just chills right there. Okay? The x to the negative 3 does need to move, so that thing's dropping down, crossing the magical fraction bar, becoming positive. R to the negative 2, can't have a negative, crosses the magical fraction bar, goes up to the top. Good? You guys gonna try this one? Oh boy, look at C, that one looks fun. When do you guys register for your spring classes? Do you know? Early November, something. I'll make my pitch when we get closer to November. I have to bring candy. What's that? Yeah, well, I only have one section of the next math class that you guys have to take. So if you like me, no, I'm not saying you have to like me, but if you do, there's only 24 seats. So you guys can rock, paper, scissors and see. Yeah, fight it out. Math duel it out. Oh gosh, I haven't even started yet. Yes. Yes. Make sure you distribute the 3 to the 2 as well. Oh gosh, I can't even read that. Brian, I'm so sorry. Just gonna be honest. I think so. Yeah. No, I think you're good. I can't. I'm just going to take one. Isaiah, I saw you in Target the other day, but I didn't want to be too awkward. In Target the other day, I didn't want to be too awkward and say hi. I had both of my kids with me. Oh, I can't remember. I was pulling into the parking lot and you were like walking in, but you were with somebody else and. Too tall. Yeah. Yeah, it's true. Okay. I had both my kids with me, so I don't know. Yeah. I've been holding on to it for 2 weeks. No, I saw you walking around and I was almost like, hey, but then my kids were like, toys. I know I should have. I'm sorry. I failed. Yeah, I have this major problem, man. I think it's a dad problem, really. Like when we go into Target, if they give me that look and they ask for toys, I'm like, okay, let's go get some. That looks awesome. Yep. We have way too many Legos in our house right now. Although my son started building it on his own last night, which made me really proud. That looks awesome. All right, let's see how they did it. Magical fraction bar, right? Crosses both of them. 3 cubed, I think, is 27 over 25. Can't simplify. Good to go. Okay? The next one, magical fraction bar for the m and for the h, right? Because you don't want to have the m squared. And I think that's as far as you can go. This one, so what they did is they flipped it, right? And then they wrote it like this. Now be careful on this one. Make sure you distribute that 3 to the 2 as well as the y to the third. But what is y to the third power? That's y to the 9th, right? It's not y to the 6th, right? That was the product rule when you have like bases. You add the exponents. But in this case, you're going to multiply the exponents and you get to there. Okay? Any questions on those ones? Okay. I don't like this one. I mean, well, it is what it is. It's the quotient rule for exponents. Basically, what this says is that if you have a base of some exponent over a base of that same exponent. Guys, I don't know, anyways. You're going to subtract the exponents. So keep the same base and subtract the exponents. So here, 5 to the 8th over 5 to the 4th is 5 to the 8th minus 4th, so you get 5 to the 4th. Okay, so that's the quotient rule. I don't know. I don't like it. I'm sorry. Okay, so for this one, what they say, well, here's what's really good. Okay, I don't know if this is helpful. This is really 4 times 4 times 4 times 4 times 4 times 4 times 4, right? Over 4 times 4 times 4 times 4 times 4. What's 4 over 4? 1, so that becomes a 1. This becomes a 1. This becomes a 1. That becomes a 1. That becomes a 1. So really I'm left with 4 times 4. What's 4 times 4? 16. So that's how I do it. I know that's weird, but especially when you get to like this thing. Well, I'll show you in the last one, but what about this next one? How we're supposed to do it, right, is we're supposed to do it as 4 to the 5 minus 7, but what's 5 minus 7? 4 to the negative what? Negative 2, but we're not supposed to have a negative 2, so this is going to cross the magical fraction bar and going to become 1 over 4 squared, which is 1 over 16, right? But if you just think about it as, those aren't even 4s. 1, 1, 1, 1, 1. So that's 1 over 4 times 4, which is 1 over 16. Does that make sense? That's how I do it. I don't know. It's easier. This last one, what are we going to have? Magical fraction bar, right? Twice. So we have x to the 12th over x to the 6th. What's 12 minus 6? 6. Oh, yeah. I'm a visual learner, so I need to like, I know writing out 12 x's and 6 x's is annoying, but that's visually, to me, an x over x lets me see that I'm going to cancel those out, right? Those are just going to become 1. All right, so any questions on that? I don't really like it. Anyways. Okay. Yeah, we're not doing those. It's way too much. So here is the end all be all. This PowerPoint is on the LMS. Everything you need to know about exponents. I can't remember what 4.3 is, but I don't think it's exponents because I don't really know what else to teach. So the product rule we talked about on Wednesday, like bases, you're going to add the exponent. The 0 exponent is always equal to 1. Negative exponents, the magical fraction bar, the quotient rules when you're going to subtract them. Then we have the 3 power rules that we talked about on Wednesday. Pretty much distributing is kind of the big thing with that, right? And then the negative to positive, we kind of hit that with the magical fraction bar kind of thought. Okay? So now, the piece of paper that I handed you at the beginning of class, that is going to be your homework that we're going to do all together in class right now, and that way you guys don't have any homework. So good job for coming to class on a Friday. Well done. So everyone, yep. So work on it for like, I don't know, 4 minutes, and then maybe less than that, 3 minutes, and then we'll go over it together as class. Does anyone have one? You guys ready? Okay. It's okay if you're not done. Okay, so how I would approach the first one is I see this 2 on the outside, so I'm doing the product rule. So for me, that's going to become 3 to the 4 times 2, which is 8, over 3 cubed. So then, quotient rule, you can either subtract those if you run or without 8 3s and 3 3s. But I'm going to take the 3 to the 8 minus 3 route. So I'm getting 3 to the 5th, which is like 243. So either one of those. Okay. All right. Second one's kind of tricky. This is 4x squared, but this is on the outside, so what do I have to do with this? Distribute it to both the 4 and to the x. So I get times 4 squared times x squared. You guys see that? So I think this 4x squared stays the same. 4 squared is 16 times x squared. I see a 4 and a 16. Those multiplied together will give you a 64. I have an x squared and an x squared. This one's kind of nice because whether you add them or multiply, you get the same number. What am I supposed to do, though? I'm supposed to add them, right? So I get 64x to this 4th power. Yeah? Good so far?
You can also write it 4 to the 3rd x.
Oh yeah, for sure. Yep. So Dawson went here, he saw 4 to the 1st, 4 to the 2nd, so he wrote it as 4 cubed, x to the 4th. Yep, either one of those works. Especially if it asks you to do an exponent form. Questions on those two? All right. First step on this one, what'd you guys do? I'm gonna flip it, right? Because I have a negative exponent, and that's gonna be raised to, man, this one's ugly. I didn't even look at it. So here, what am I doing with the 2 now? Distributing it everywhere, right? So I should get 6 squared over 5 squared times y to the 4th, right? So that's, do I have any negative exponents? No. That could be your answer if you want to go a little bit crazier. You can get 36 over 25 y to the 4th. Either one of those work. Jeez, how'd you guys do D? Should have looked at these before I gave them to you. What am I gonna do with the negative 2? That's what I would do. The first thing I would do is distribute this guy in here. So I'm getting 3 to the 9th times x to the negative 4 times y to the negative 2 all over 3 cubed times x to the negative 4 y, I'm going to put a 1 there. Does everyone understand what I did? Distribute in the negative 2 and then just kept the rest the same. So 2 times negative 2 gives you a negative 4, and this is technically a 1, so 1 times negative 2 gives you a negative 2. Okay, good so far. Here's what I do. Let's deal with these things one at a time, right? Or else I get super confused. I have 3 to the 9th over 3 to the 3rd, which becomes 3 to the, what's 9 minus 3? 6, right? And that's going to stay on the top. What's going to happen with my x's? They're going to flip-flop, right? Magical fraction bar, magical fraction bar. What's going to happen to my y to the negative 2 on top? It's going to go where? To the bottom, right? So then I get y to the 1st, y squared. You get with that? Kind of, sort of, maybe? Kind of. So I had a negative 2 up here, so I had to take it down to the bottom. My y to the 1 is going to stay down there. My x to the negative 4 on top is going to go to the bottom and become x to the positive 4, but my x on the negative 4 on the bottom is going to go to the top and become x to the positive 4. What's x to the 4th over x to the 4th? 1, right? So this becomes a big 1. Hate's a strong word. What's left on the top? 3 to the 6th. And then I have y to the first, y to the second, which becomes y to the 3rd. So that should be your final answer. That one was super tough. All I can say is take them one step at a time, right? So in that one, distribute in your -2. I like separating them, so I've got my bases of 3, bases of x, and bases of y. It's hard for me to look at it as one big clump because I get overwhelmed. That's why I can't read thick books. Like, if you hand me if I were to pick out a book that's like thick, I'm not gonna read it. Like, I automatically get overwhelmed. Like, even if I love the subject, I'm not gonna do it. So anyways, I need to break things into chunks. So I break into 3s, break into x's, break into y's, and deal with them one by one. Okay? Is the last one worse? Oh, jeez. We got it. We got this. Oh, easy. Oh, this is easy money. Okay. What am I doing with here, did you guys see this? Base of 8r, base of 8r. What can I do with those exponents? Well, I don't have to distribute if they're the same base. What do I do with the exponents? Just add them. So what's 4 plus -3? 1, right? So this is just 8r to the first. Same thing down here, right? So what's -8 plus 10? 2. Now what does that simplify to? This is what I have visually. What happens to the 8r over 8r? Crosses out, so what am I left with? 1 over 8r. 1 was D then. D was worse. Did you guys see that? You can distribute if you want. That just gets, especially with the 2 bases in there, because it would have to become 8 to the 4, r to the 4, 8 to the -3, r to the negative. I mean, you know what I mean? If you can recognize that those are bases of 8r, bases of 8r, bases of 8r, bases of 8r, and add them, you're good to go. Okay, so I just went in and I gave everyone credit for 4.2 homework, so no 4.2 homework. 4.1 homework is due on Monday. 10 questions, make sure you guys get that done. If not, have a great weekend. We'll see you on Monday. Recording.